Good afternoon. My name is Marcus Wenda. Who here is taking a meteorology class? Yeah, quite a few of you. So you think you know how weather works? You're wrong. You never know too much about the weather. Did you know over 20% of all aviation accidents are caused by inclement weather? We may not be able to control it, but we can decide if flying in it is our best option. Today we're going to be learning about the different types of fronts. There are 4 different types of fronts. We have warm, cold, stationary, and occluded. Occluded is generally shown as purple. However, good luck finding a purple dry erase marker. So today I'm showing them in orange. You'll see these different symbols on a surface analysis chart and the prognostics chart. So what is a front? When an air mass moves out of its source region, it comes in contact with other air masses that have different moisture and temperature characteristics. The boundary between these air masses is what we call a front and often contain hazardous weather. It is often easy to tell when crossing a front due to the change in air temperature. A cold front separates an advancing mass, first of all, cold front, and it is shown by the blue line and blue triangles, and those triangles point in the direction that the front is moving. So a cold front separates an advancing mass of cold, dense, and stable air from an area of warm, lighter, and unstable air. Because of its density, the cold air moves along the surface and forces the warm air upward. During passage of a cold front, you can expect towering cumulus or cumulonimbus, and we have some examples here. Those are known by the anvil tops of the clouds, and heavy showers. Hail, lightning, and thunder are also possible. Visibility is usually poor, and wind is generally variable and gusty. The temperature and dew point will both drop, and the pressure bottoms out and then rises rapidly as the front passes. Warm fronts are shown here, are a red line with red scallops on it, and those scallops point in the way the front is passing. And they occur when warm air moves over the top of cooler air at the surface. They usually move at much slower speeds than cold fronts. The slope of a warm front is very gradual, and the warm air may extend over the cool air for several hundred miles ahead of the front. The stability and moisture content determines what types of clouds will form. If the air is warm, moist, and stable, stratus clouds, which are shown here, and steady precipitation can develop. If the air is warm, moist, and unstable, cumulus clouds and shower precipitation can develop. During passage, you will generally see stratus-formed clouds, which are shown here, and there might be a slight drizzle. Visibility will be poor, but improve as the front passes. Wind will be variable and most likely fairly light. The temperature will increase as the dew point stays constant. The pressure will steady out as the front passes. Next, we're going to discuss occluded fronts. And remember, these are shown in purple on your charts. An occluded front occurs when a fast-moving cold front catches up to a slow-moving warm front. There are 2 types of occlusion, warm and cold. In a cold occlusion, the air mass overtaking the warm front is cooler than the cold air ahead of the warm front and plows under both air masses. In a warm occlusion, the air mass overtaking the warm front is not as cool as the cold air ahead of the warm front and rides over the cold air mass while lifting the warm air. Occluded fronts usually form around mature low-pressure areas. During passage of an occluded front, nimbostratus clouds will most likely form. You'll experience light to heavy precipitation with poor visibility. Wind will be variable and can range from light to moderate, and the pressure will gradually become steady. Lastly, stationary fronts, and they're shown here with the blue triangles and the red scallops intermittent, and they point opposite directions, and that shows that the front is stationary, it's not moving. And stationary fronts do occur when opposing forces of 2 air masses are balanced. The front that separates them may remain stationary and influence flying conditions for several days. The weather in a stationary front is usually a mixture of what you'd expect in a cold and a warm front. Now, I recommend reading more up on fronts and all different types of weather. And the Jeppson's Guided Flight Discovery Instrument and Commercial Textbook is a great resource for that. So remember that when a front passes, expect a weather change. And even though we can't control the weather, we can make sure that we don't become a statistic. Thank you.
I like dudes.